Okay, Algebra 2, I am on page 617. We're going to do example 2 today. Real quick, I want to talk over a little bit we talked about last week. So the ellipses, remember, are like ovals. All right, so we're going to use these formulas here, standard equation. Remember, this is slightly different. Okay, so because we flip the x's and the y's from this one to this one. So the very first one is for a horizontal ellipse, and then the second one is for a vertical ellipse, right? So this is our horizontal, and this is our vertical ellipse. Now, reminder that a horizontal ellipse looks like this, and a vertical ellipse looks like this. Okay, and I know I've done a very sloppy job of drawing this, but I want to reacquaint you with a couple of words you learned last week. All right, because in the problem, example 2, it says they gave us vertices and co-vertices. Okay, so you see how this is the major arc, sorry, not the major arc, this is the major axis here. Okay, so this point and this point are the vertices. So the major axis would run this way in the vertical one, and this means that these are the vertices, which means the minor axis, right, which is like here and here, the short way, the blue dots then would be the co-vertices. Okay, so I'm going to use those here in a second, but I just wanted to bring you back to that before we start example 2. Okay, so they say the vertices, all right, I'm just going to put a V here. Right, so the vertices are, let's see, 6 and negative 8. Okay, and the other one is 6 and, what is that, 4? There we go. And then the co-vertices, okay, the co-vertices are 3 and negative 2 and 9 and negative 2. Okay. First things, we're going to look at the first point, or the vertex points. Do you guys see how the x's are the same? Okay, in the vertex, in the vertices, the x's are the same. Okay, that means that this is a vertical. Right? It's a vertical ellipse. Notice in the co-vertices, the y's are the same, which also means it's vertical. Okay, so if the x's are the same, it's vertical. If the y's are the same of the vertices, it would be horizontal. Okay, now the co-vertices, the x's would be the same for horizontal. All right, so remember, if you see x being the same, it's vertical, which is important because it's going to tell us how we write our answer. All right, so we'll come back to that in a second. Actually, I want to bring this back for a second. So let's look at our formula here. Yes. Okay. Remember, we're going to need h and k, which is the center, and then a and b, which I'll teach you how to figure that out in a second. Okay. It involves with our major and minor axis, right? 2a and 2b. Okay. So coming back to this, we need the center. Okay. So if you think about this, this is the major arc, right? Or I keep saying major arc, thinking geometry here. The major axis, right, which runs this way. So look at the line I just drew. Halfway between this point, between these 2 points, right? Halfway between should be the center. So we have a formula for halfway. It's the midpoint formula, which looks like this. x1 plus x2 over 2, comma, y1 plus y2 over 2. Hopefully you guys remember that for midpoint. So let's do the midpoint of the for the vertices here. All right, so the x values are 6 and 6. So it's 6 plus 6. It's 12. And then we have 12 over 2, which reduces to 6, right? The y values, going very quickly here, plugging them in up here. I have a negative 8 plus 4 over 2, which is clearly 4 over 2, which is 2. So it looks like the center is 6, 2, right? We just, excuse me, this should be a negative 4, which makes it a negative 2. So 6, negative 2 is our center, which is our h and our k. I'm going to put a little star by this box because we will need it in a second. Now, I want you to think. Of how we can now solve for a. Well, a is the major axis. The distance of the major axis is equal to 2a. So we find the distance of the major axis, which were from vertex, vertice to vertex. Oh boy, sorry, Monday here. Vertex to vertex. If we find the distance of those two, that will equal 2a. Right, so that's what I'm going to do. Distance formula looks like this. Distance equals, oh yikes, x2 minus x1 squared plus y2 minus y1 squared. All right, so let's plug them in there. We're going to find the distance here. So I've got 6 minus 6, which is clearly 0, right? So we got 0 squared. So I have 0 plus. Let's plug the y2's in. So I have negative 8 plus 4 squared. Minus 4 squared is a negative 12. Negative 12 squared is 144. So I have 0 plus 144. It looks like the distance of the major axis is the square root of 144. Right, now I use d for distance, but don't forget, right? Don't forget that really this d, we can simplify that to d equals 12, right? Because radical 144 is 12. So if I take my 12 and I set it equal to 2a, right? 2a was the major arc. So if I say 12 equals 2a, what does a equal? Well, a is 6. So let's do that down here and put a equals 6 below our h and k. Now, unfortunately, guys, we're going to have to do the distance formula again. Okay, we're going to have to do it for the minor arc. There's the arc again. For the minor axis, which is 2b. All right, so we're going to do the same thing, but now we're going to use the co-vertices, all right, the co-vertex. All right, so same formula up here. I'm just going to go ahead and plug them in here. Remember, we're saying x minus x. So I'll say 3 minus 9 squared plus, and then y minus 1. So negative 2 minus a negative 2 minus minus is plus. These cancel, so that's 0 squared, which is 0. 3 minus 9, 3 minus 9 is a negative 6. Negative 6 squared is 36. 36 plus 0 is still 36. So it looks like d is equal to the radical of 36, which everybody knows is 6, right? Okay, so it looks like the distance between these 2 points is 6. And what we will do is we will set that equal now. Minor arc, remember minor is equal to 2b. So we say 6 equals 2b. We divide by 2, and b will then equal 6 divided by 2 is 3. Okay, lots of things happening here. I know I went very quick, but we're going to go ahead and plug our h and k and our a and b into our formula. So I'm going to come to this page here to remind you we have a vertical formula, which is a vertical ellipse, which is y minus k. All right, I'm going to try to find a way I can put both these on there for you. There we go. All right, y minus k. So we say y, what was our k? It was negative 2. So if we have a minus a negative 2, it becomes plus. So I have y plus 2 squared, right? And I'm going to put it over a squared. Now a squared, a was 6, so a squared was 36, right? Where is that down there? So we say over 36 plus, I want to say x, where's my sheet, x minus h. What's the h? 6, so I say x minus 6 squared over b squared, right? It goes over b squared here. B was 3, so 3 squared is 9. And it's always equal, run out of space here, always equal to 1. So this is the equation of that ellipse. All right. Now, the last thing I want to do, you guys, is I want to look at guided practice 2. All right, so it's just below example 2. Okay, so just look at the points they gave us, right? Because you guys know how to use distance formula and the midpoint. But I want to look at the points they gave us. So the vertex points were negative 3, 8, and 9, 8. the covertex, the covertice are 3. Where is that? 3, 12, and 3, 4. All right, we're not actually going to do this problem. I'm just going to point out that this one's different. All right, so let's come back to our first problem here. All right, here we go. The first one we did, I'm just going to look at the vertices here. 6 and 6, the x's were the same. Let's look at the vertices here. See how the y's are the same? Okay, so if the x's are the same, it was a vertical ellipse. If the y's are the same, it will be a horizontal ellipse, which means you'll use this formula up here. Okay, everybody see that? Notice that the y values of the covertices were the same, but down here the x values of the covertices are the same, which also means it'll be horizontal, which means we use this. Okay, so you have to check to see if it's vertical or horizontal before you begin to solve. Then you do your distance, your midpoint, and you plug things in. Okay. If you have any questions, you guys, you can see. Let's see, information on page 615. The key concept box will show you the length of the major axis, minor axis, in case you forget. If you have any questions, please leave them in my comments down here, and I will try to help you out as much as I can. I want you to try a couple of problems for me, guys. Yep, a couple. So page 619, all right, I want you to try numbers 3 and 4. Good luck. If you have any questions, please let me know.